I'm going to be talking about achieving moisture balance. Moisture is my expertise. And I'd like to talk about a couple of points which are related to net zero. One is moisture safe construction, and the other is innovative building fabric solutions. Before that, I would like to briefly introduce the UK Centre for Moisture in Buildings, which I'm part of. Our aim is the development of a moisture safe built environment. And we are based at UCL IED, but we are collaborating with a large number of stakeholders from industry, government, academia, and also with the public. And our aim is to substantially improve the way moisture is dealt with in the built environment. So this is an example on a moisture balance building. And when we talk about moisture balance, we think about two main things. One is health, so the health of occupants, and the second is the durability of the building fabric. And these two are key areas for a net zero future. If we think about health, we also think about comfort. This is very important. And we are all very much aware of the issues associated with poor health in indoor environment, particularly related to mold growth with the tragic death of a child 2 years ago. So another thing that is very important is weather protection. And regarding durability and moisture in buildings, durability of buildings can help us extending the building lifespan. So considering the building beyond its designed lifetime, and also can help us reducing maintenance and replacement of components. And at the end of the lifetime of the building will help us to reuse building materials if a moisture balance is achieved throughout the building lifetime. So these are all opportunities for a moisture balance approach. However, what we normally find in the built environment is that this balance is tipped. So we normally deal with moisture imbalance in our buildings. And this is again affecting our health and durability of our buildings. So a couple of figures related to health, and then I'll talk about a bit about durability as well. So one of the key figures that we found in the Energy Follow-up survey is that overall 27% of households reported presence of some damp or mold patches in their building, in the property where they live in. This is quite different from what we normally find in the English Housing Survey results. They normally talk about 4%, but then when they actually went to survey a sample of buildings, they realized it's overall around 27%, which is a much higher figure than what was estimated from in the English Housing Survey. So this is the key point, is we actually have many more moisture issues than the usual statistics tell us. And then it's costing the NHS around 1.4 billion per year to treat those people that are affected by poor housing. And mold and damp in buildings are two of the main causes of poor housing in buildings. So these are first year costs alone, so the treatment that is on the first year, but there are also long-term consequences, as we know, particularly related to asthma exacerbation, which it's estimated that around more than 18 billion a year is actually related to overall care, so healthcare and social care related to poor housing. So this is the key issue, and mold and damp, which are related to moisture, they are contributing to this issue. So definitely we have some challenges here. And I just want to show you some example of moisture excess. So with moisture excess, we talk about, we refer to mold and damp that we find in buildings, and we can find it at different levels. So these are just examples from some of our surveys, and we have thousands of pictures of mold. I know they're not very nice to look at, but I love pictures of mold. So if you have any, please send them to me. My email address is at the end of it. And we normally, it's great to have such a variety of examples of what can go wrong so that we can improve design and operation of buildings. So this is an example of mold growing indoors. So this is growing on a surface, mold grows on surfaces, but the growth is very much related to very high moisture levels indoors. This is a still mold inside the building, but that is an example of a combination of fairly high levels of moisture, but also a cold surface. So we tend to divide the two issues, and we have indoor airborne mold, and then this is a combination of airborne high moisture levels, but also cold surfaces. And then we have moisture excess within the building fabric, and this is particularly important in traditional buildings, and we really need to minimize that. But it's also a case of poor installation in new buildings. So this is something that we don't normally think about when we do design, but it's very important to start considering it, because one of the key issues that we find when we do surveying, when we survey buildings, is that escape of water is almost as important as mold growth indoors. So we have a high number of design choices which lead to escape of water. So poor design choices like flexible ducting or like services, plumbing that are not as robust within the lifetime of the building, they lead to really serious consequences. So this is an opportunity to think about design, not just the design of the building and the services, but the design of each, the specification of the components which are part of your design. So these are the challenges that we have. But what's the answer? So to ensure moisture balance, we really need to adopt a whole building approach, and not just in design. We need to adopt this approach throughout the construction process. And this is in line with a number of other challenges that we have in the net zero transition. So for energy, we also need a whole building approach, but for moisture it's particularly important because the moisture issues are at the interfaces across the different disciplines and the different parts of the building as well. So what is a whole building approach? I think Rakaya mentioned about that before, mentioned about the need for a whole building approach. And that is an approach that takes into account the interactions between fabric, people, and services, but also considering the contextual elements of the building, and then considering the past history and possible future changes of the building. This approach, from a moisture perspective, we try to boil down this approach into 4 C's. So 4 principles, which are context, considering the context of our building, both existing and new building. Coherence, considering the coherence across the different, across services and fabric, the interaction of the different building elements, and also coherence between design, installation, and use. Capacity, including robust approaches in the design. So not over-optimizing, but thinking about robustness, thinking about systems that are able to withstand different conditions to what we were designing for. And caution. So what I think about when I think about caution, when I see caution, is about monitoring, long-term monitoring, using IoT solutions that can help us understanding more about the building and understanding how our building fabric, for example, is performing, whether there are some issues in the building fabric, whether we need to do maintenance, and whether we need to consider replacement, for example. So we have the technology now. We should be able to use that. So a lot of this is in the British Standard 5250 that we worked together with a large number of stakeholders, of course. We worked on until 2021, so that is published. And this is something that is very important, is that moisture safe design cannot be done in isolation. Normally it's left when the risks are clear, but it's really important that that moisture safe design is considered together with the other design issues. So for example, when I think about traditional buildings, and historic buildings with heritage value, heritage can be another of the design aims and objectives. Carbon is one of the objectives, energy use is another, comfort. So we really need to consider moisture as part of a whole. And we need to balance it against the other key design aims. So we understand this is a challenging point, and that's why we have been developing frameworks to support moisture balance at scale, because we have really excellent examples on individual projects where moisture balance was achieved with very careful detailing and very careful design and attention to detail during installation and commissioning. However, we need to have a moisture risk assessment, design and management that is easy to access for every professionals, not just the flagship building, but also every small dwellings that need to be retrofitted. So we have developed some frameworks integrating multiple design aims. In particular, we have integrated energy and moisture, and it would be great to start working on a larger number of design aims that can be included here. There are also a number of tools, like the STBA guidance wheel is a common tool for traditional buildings, and we hope to be able to have more tools across the building industry. On our website, we have a number of tools and videos that can be useful for understanding more about moisture risk. I think one important thing that Espen mentioned is assessing building compliance, not based on design, but based on operational performance. And this is very important, not only for energy, really important for moisture too. So there are a lot of synergies between moisture and other design aims. And then, yes, this is what I wanted to mention before about using IoT. So really targeting the monitoring of critical areas. We are aware what interventions can be more critical, so we can have hard to decarbonize homes, which have elements like solid wall insulation that can be critical, and having targeted monitoring can give us peace of mind, can give us awareness on when our solution is getting towards the end of its lifetime, and can really help us with planning ahead. So now I just want to give, I know we are late, so I'll be brief. Just want to briefly mention about other opportunities related to net zero and moisture. So we have been recently, so I've been working on natural bio-based materials in the past 12 years, yes. And now I can see a lot more interest in developing solutions based on natural materials, because it's seen by architects, for example, as one of the potential directions for net zero, as we were mentioning before about the need for understanding embodied carbon. So there is an interest, growing interest compared to when I started. When I started, we were just a few hippies talking about wood fiber. Now there is a lot more around that. And there is also an interest in looking and using local materials. And understanding the moisture balance of this material is also, it's very important, because these materials are allow wetting and drying, so we really need to achieve a moisture balance, but also appreciating the opportunities that these materials offer by balancing the indoor environment. So just a brief overview on some projects that we, that have been happening across the world. So this is a strawberry cottage, passive house, so bringing in really strict performance requirements with natural materials. These are other examples of, this is a modern method of construction, so manufacture of site, wood fiber insulation installed on external, on the external facade of a traditional building. And this is a round earth example. With this, I just want to mention that natural bio-based materials don't need to be isolated from innovation. They are part of an innovation strategy. So innovative strategy that can really help us developing towards a net zero strategy. I've seen a lot of innovative strategies that need to use materials that are not necessarily appropriate. So I think it's important to learn from the past and then adapt to the new, to the future. And this is something that, again, transition to net zero, looking at retrofit. In terms of internal insulation retrofit, sometimes we don't really see the result because it's so well done that we don't see the influence of a retrofit on the appearance of a building. So this is it's an example at Trinity College, Newport in Cambridge that we've been working on, and it's been insulated in conjunction with a ventilation strategy, and been using natural materials and being monitored for a number of years. So with this, I just want to say, technically, we have the knowledge. The challenges for this, it's first understanding moisture transfer of every system, not just natural materials. But natural materials allow drying, so really use that, making sure that the building is dry. It's very important. And then, yes, robust solutions based on natural materials are available for many applications, including internal insulation, which is seen as one of the most risky applications. But we have a number of years of evidence that these systems work. Of course, other non-natural material solutions work as well, but I can see there is a tendency to be a bit more concerned about natural materials because of their degradation, but actually they are as good or even better than some other materials. Moisture assessment, design and management is still needed. So we need it for conventional materials systems, and we need it for bio-based systems. But the most important thing here is that we need to upskill all the construction professionals in the supply chain and provide guidance to residents and clients, because without upskilling the workforce, we are not able to deliver any of the net zero strategy, particularly on if we look at fabric solutions. And it's not just about natural material, it's about all systems across the board. With this, I just want to mention that we have a conference every 2 years, the International Conference on Moisture in Buildings. So if you're interested in discussing of moisture with us, it's going to be on the 3rd and 4th of July here in London and online. Thank you.